Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to be taking a look at exponential equations. So let's go ahead and get started. Now, when we're talking about an exponential equation, we're basically talking about when you have numbers, bases if you will, that have exponents to them. So again, the easiest way to understand this is to see an actual example. So here's our example. Imagine we have here 3x minus 2, that's to the raise to that power, equals 81. Now, in order to solve this equation, you have to make sure that on both sides of the equal sign, the numbers have the same base. When they have the same base, all you simply have to do is just take the exponents and solve for whatever the equation is, solve for the x. Now, on our left, we have 3 raised to the 3x minus 2 power. That's pretty much already set up because there's no perfect number below this. This is already a prime number essentially, whatever the term is. So what we have to do now is we have to find a way to deal with this 81, change it so that it has a base of 3. Now, there are many different ways to do this. One way is to just make a like a tree, a factor tree, like so, and just keep working your way down until you get down to the lowest numbers, if you will. So if I did it like this, I would have, let's see here, 9 and 9, and then break it down here, 3 and 3, 3 and 3. Now here I cannot go any lower, so I know that another way to get the number 81 is to have 3 to the 4th power, because I have 4 3's here. That's how it is. So in other words, if I were to try to simplify my current equation, it would be 3 to the 3x minus 2 power equals 3 to the 4th power. Because if I multiply 3 4 times, I'll get right back up here to my answer of 81 right here. Now that I have the same base on both sides, I can ignore the bases and just solve for x in a simple equation. And to show you what that looks like, let's just do the following. So now I have 3x minus 2 equals 4. I just removed the bases of 3. And so this is just basic algebra. There's nothing new here. Just add 2 to both sides. You can see that. I have 3x equals 6. Divide by 3 on both sides. And I get x equals 2. And I can check that. So let's see here. If I put 2 in here, I'd be 3 times 2. That'd be 6. 6 minus 2 is 4. 3 to the 4th power equals 81. It makes sense. So we know that answer is correct. So let's move on to our next example here. This next example is a little bit trickier, but if you sit down and think about it, it's not as hard as it looks. So now I have 7x to the minus 3 power equals 7. Now you might be thinking, oh, we're in trouble because you cannot simplify these 7's anymore. I mean, this is it. There's nowhere to go. However, if you just think for a moment, when you have 7 like this, it's the same thing as saying 7 to the 1 power. Of course, we never put that there because 7 to the 1st power is 7. But essentially, what you now have is, if you think about it like this, is you have x minus 3 equals 1. You add 3 to both sides, and you can see that x equals 4. And then you can check. 4 minus 3 is 1. 7 to the 1st power is the same thing as 7 to the 1st power. It works out. Let's do our final example here and wrap this up. Now this time we're going to be dealing with logarithms. Not logarithms. We're going to call this Euler's number, E, a very famous number in mathematics. Let me see if I can write this for you real quick. And so imagine we have the following. We have E to the x power raised to the 2nd power like that. That's essentially very complicated. Raised all the way to e to the 3rd power here. And all this equals e to the 2x power, like so. Now, one of the things about exponent properties is that you can have the following. Whenever you have a to the m over a to the n, it's the same thing as a to the m minus n. So if I want to simplify what's happening on the left-hand side here, this section right here, I can do it as follows. I can make it e to the x squared minus 3, following this formula right here, following this example right here from the exponent property, equals e to the 2x power. Now, we already have the same base, and that's Euler's number right here. We have the same base, So now it's just basically x squared minus 3 equals 2x. And so you just do some basic rearranging here. So I want to move all of this to one side. So minus 2x, minus 2x. And so what I end up with is a quadratic function. Quadratic function, x squared minus 2x minus 3 equals 0. And just some basic factoring. So essentially I'm looking for something when I multiply it, it becomes up to negative 3. When I add it, it ends up being negative 2. And so, you know, just to give you a shortcut here, I have x minus 3 and x plus 1, because minus 3 plus 1 will give me minus 2. Minus 3 times 1 will give me negative 3. That's how I know. And so we end up with two answers here. Essentially, x can be one of the following. X can equal 3 or negative 1. And you can check that for yourself if you desire. So that's that's an introduction into dealing with solving exponential functions. And so you can see how that works out. But let me go back and review before we conclude the video. So we looked at, again, like I just mentioned, how to solve exponential functions. And the key, essentially the number one rule that you need to remember from this video is that you must find a way to make sure that both sides of the equation have the same base. Once you have the same base, it's just a matter of solving it using basic algebraic ideas and concepts. And so to get the same base, sometimes you have to make a factor tree, or you have to find other ways to do it. It all depends on the situation. But the fundamental core ideal is they must have the same base. So you can see this first example. In the second example, it already had the same base. You just had to be aware that when you're already got something that cannot be simplified, it's the same as raising to the first power. And then in this last example, you had to have knowledge of the exponent properties in order to deal with this, because we had to simplify this so that we can deal with the stuff on the right hand side of the equal sign. And so by simplifying this to having it being e to the x squared minus 3, which is the same thing as these dividing by each other, we did have the same base, and we could solve using basic algebraic ideas. So I hope that this was useful for you and you were able to understand what we were talking about. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.